Oh, hello everyone. Let me know if I'm audible. Let's wait for a couple of minutes so that few more people join. Till then, let me know if I'm audible and everything is visible to you. Okay. Okay, sure. Yeah, let's wait for one more minute and then we can start off. Okay, so for the people who are here, let me tell you that today I will be discussing questions which were asked in Walmart interviews, and I picked two problems again. So as you all know, the streams which I take are divided into two parts. One will be from 8 to 9 and the other one will be from 9:15 to 10:15. Okay, so I have picked two problems. One is of hard level and one is of medium level. Both are popular problems only, but again they involve some good concept which can be learned from the very basic. Okay. And yeah, this is thing which I wanted to tell before starting, and then we can move ahead and see how the session goes. Let's wait for few more seconds more and then we can start. Till then, you can share the link with your friends or colleagues who would like to come, and we will have a good discussion out here. Okay, so let's start. First of all, let me introduce myself for the people who have joined this session for the first time. Myself Shashank, and I currently work as a software engineer at Inference Labs. Previously, I was working with ClearText as an SD1. I interned at Red Hat and I was into ACMI CPC 2019 regionals. And I have around 1+ year teaching experience as well. The subjects which I'll be taking are DSN, C++, and interview preparation. So this session is a part of interview preparation. Okay. Okay. So let me just quickly tell you this career as a developer subscription. So all the people who are into software development or who want to start off with software development, then this is a very interesting show for all of them, and you can definitely take this up. So let me just tell you a few points regarding it. So here you will be told about all the companies which are hiring and how to apply to them. So you will get updates about the openings and all those stuffs. Then there will be HR talk shows where the HRs of the major companies would be coming and they would be telling about their hiring procedures and everything. There will be live problem solving, okay, and there will be over the weekend projects. And there will be one more thing, that is the people who are already placed in some major companies, they would be coming and sharing and share their journey as well, like how they got placed and everything about that. And you get all these things clubbed under one package for just $999 for a year. And if you use my code as Pathak10, then you can get 10% off and you can avail it for $899. Okay. Now coming to this part, college projects. So basically, as I told you, it comes under this Unacademy's career as a developer subscription, and it's taken by Raj. And it takes place every Friday night at 10 p.m. Okay, and as I already told, it's a part of that Unacademy's career as a developer subscription. So all those people who are in the college or even they have graduated or something like that, and they don't have some good projects or they want to apply for internships and full-time opportunities at various companies. So this can be a very good platform for all of you, where you can learn and take guidance from Raj and kind of fill the gaps which are there in your projects, or you can even take up the idea and take guidance like how to build a project and how to make an impactful project. Okay, all those things around. Coming to this, the Courtship Apprentice. So it's a show that is taken by Sai Avinash, who is currently working as an SD at Google, and he's also 7-star at Courtship. So this show already started from 14th of August, and it takes place every Saturday afternoon at 2 p.m. So all those people who are into competitive programming and who are like trying their hands there, so the ones who are trying to like increase their problem solving abilities and improve their ranks and ratings on various competitive programming platforms, so they can surely like have a look at it and surely avail it. And one more thing, like since Sai Avinash himself is like a very strong competitive programmer, so you will be able to learn many tips and tricks, and you can as well get your queries resolved and see how to solve a problem. He will be doing live problem solving as well. Okay, fine. So do like, share and subscribe the channel, and do share this link with all of your friends and colleagues, so that they can also join and we can have a fruitful discussion out here. You can join the Easy Code Unacademy Telegram channel as well for all the updates and notifications. Okay, so now coming to the main part. So today I'll be as I told, like I will be taking two problems: trapping rainwater in the first session and right view in the second session. So basically this interview cracking series, the sessions which I take are divided into two parts. The first session, which will be from 8 to 9, and the second, which will be from 9:15 to 10:15. Okay, so let's begin. So let me just tell you like how I basically take these sessions and how it goes on for the people who have joined for the first time. So I'll be taking a problem and I will be solving it in a way that I've encountered this problem in an interview. Okay, and in between I will keep telling you like, okay, yeah, like some good like kind of tips, so that you can apply that and you can surely like ace in your interviews. Okay, fine. So let me know if it is all good to go and I can start off with. Just write a yes if everything is good and I can start off. Okay, so I'm assuming that everyone is good and I can start off with it. Fine. And guys, like try to be responsive so that we can have some good discussion, and I will even take your approaches as well. Okay, so yeah, let's begin. So the problem says given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. Okay, fine. So we are given some height of the bars and they are along some axis, and the width of each bar is 1, and if like there will be some histogram type of stuff, and if there is a rain, then how much water can be trapped between them. Okay, so the problem says something like this. Let me draw it. So suppose this is my axis. Okay, this is my axis. So the first bar is of height 0. Okay, the second, let me just denote it by 1, 2, I think so max 3 is there. Yeah, max 3 is there. So the first bar is of 0 height, correct? The second one is of 1. So I will start from here, fit 0, then again it is of height 2, so I will take this, then 1, okay, then again 0, then again 1, then a bar of height 3, then a 2, sorry, that's 2 length. Okay, let me again draw it. So it was of 3, then I have of 2. Let me just do it. Then I have a bar of height 1, then again 2. Okay, then again 1. Fine. So what a question says कि अगर बारिश होती है, like if there is a rain, ठीक है, so how much water can log or how much water will be trapped basically, ठीक है. So can we see कि over here let me just change the color. Over here water will be trapped. Okay, at this part water will be trapped. Over here the water will be trapped. Water will be trapped till here for this portion, and water will be trapped over here. Okay, rest I think so water will be trapped over here. Okay, yeah, that's it, I suppose. Or yeah, water will be trapped here. So how much area we have contributed? 1 from here, basically 1 from here, from this bar, 2 from here, 1 from here, so it becomes 5, and 1 from here. Correct. So how much water is logged? 1 plus, if we add them all, so it will be 4 to 6. So 6 is our answer. Okay, so 6 units of rainwater, which I have denoted in the blue section, will be trapped. Is the question clear to everyone? Just let me know, then we will move ahead. Is the question clear to everyone? Let me just draw this as well. So there will be something like 4, 2, okay Rahul, 0, 3, 2, and 1, 5. Okay, fine. And if I see over here how much water will be trapped, कुछ इतना यहाँ पर होगा, ये पूरा इतना यहाँ तक होगा, और somewhere around here. Okay, this much water, this much over here, and this is of height 4, this is of height 2, this is a height 0, this is of height 3, this is of height 2, and this is of height 5. Okay, so if I look over here, how much water is trapped now? How much water is trapped over here? 2 units over here from this part, 4 units from here. Okay, 4 units of water here till here basically, or I think so till here only I can take, not 4, it's 3 units over here. Then I will have some water trapped here, and that will be of 2 for this bar. For this bar I will have 1. So how much I am having? 8 units. Where is 1 unit left? There is one more, because the answer is 9. So we have over here 2 plus 3 plus 2 plus 1. So it comes out to be 7 units. 3 plus 2, sorry, 8 units of water. We are missing 1 unit of water. So I've made a messy diagram. 2 for this bar, 3 for this bar, correct. Then for this bar I have 2. I have 1 unit only, because only this much water will be trapped. 2 units. Okay, over here. Okay, so over here basically 3 units of water will be trapped for this, not 3, not 1, 3 units of water. So if I add these all, so, and over here 1 unit of water will be trapped. If sorry, my bad, because over here I can take up till only 4. So for this 1 unit of water will be trapped, for this till here like 3 units of water. So now it comes out to be 3 plus 3, 6 plus 2, 8 plus 1, 9. Yeah, so now it's perfect. Okay, fine. So whenever you are in an interview and you get a question from the interview, that he places a question, you read the problem, so always try to like rephrase the question and explain a problem, like a sample example to the interviewer to clarify ki, okay, whatever you are understanding is right or not. Okay, so as I did over here, I made a bit mistake, but yeah, I tried to rectify and kind of clarified it. Okay, so 3 plus 1 and then 3. Okay, so what is this? That turned out to be 9 units. Okay, fine. Now let me quickly draw a histogram once again, this basically this one, and then we can try thinking how can we approach this problem. Okay, so let me just quickly write down the numbers over here so that I won't have to again and again go above. Okay, let me draw a histogram, and it would be good like if you all can solve the problem along with me, right? So sir, I think this will be water. 2 4 1 2. Okay, so you are saying trapped. Okay, 2 4 1 2. So over here 2, over here you are saying that 4 amount will be trapped. 4. Okay, fine, okay. Why I took it that way? Okay, fine. Let me just see. 1 unit over here, that is for 3, so 4 is there, so I will be getting 1 unit over here. Yeah, correct, I took that right. Then for 2 you are saying I will be having 2 units over here, and that will be till 4. Okay. Yeah, I took it for 5, right? So how much it is? 4 plus 2, 6 plus 8. Yeah, correct, Raul, correct. Exactly. Sorry, I messed up with the diagram again. Thanks a lot, Raul, for correcting it. Okay, 2 plus 4 plus 1 plus 2. Correct, yeah. So this will be the sequence for this, basically. Okay, my bad. And it turns out to be 9 units. Okay, fine. So thanks, Raul, again for pointing this out. Now let me draw the histogram again for this, and let's see how can we think of it. Okay, so 1, I will quickly draw it. 1, it will be 2, it will be 1, then 0, then again 1, then a 3 kind of over here, then a 2, then a 1, then a 2, and then again a 1. Okay, so this was my histogram. This is my histogram basically, and as we discussed, where water will be trapped? Here, over here, this part, okay, and what we discussed, okay, this part, correct, this part, fine. And this comes out to be how much it was? It was 6 units of water, correct? 6 units of water. Let me just quickly write down the height for these. 1, that was 0. Let me just write down below. 1 0, 2 1 0, 1 3, 2 1 2 1. Okay, so this was our given array. Okay, and now we have to find out how much water is trapped. Correct. Okay, so let's think in this way, कि how much water, like I'm just trying to approach this problem in this way, कि how much water can be trapped above each bar. Okay, मतलब अगर देखो, अगर if I see over here, तो I'm only concerned about कि इस बार के ऊपर कितना वाटर लॉग हो सकता है, इस बार से कितना वाटर लॉग हो सकता है, at this bar how much water can be logged at this bar. Similarly over here how much water can be logged, if like 0 is also like can be considered, there is no bar but we can consider it, okay, this is also a bar and above it how much water can be logged. Similarly for every other bar. Okay, so how much like my problem boils down to how much water is logged above each bar. This is my concern, and if I add all of them I will be getting my answer. Okay, so this is a very key observation, which I feel is very important for our solution. Okay, Soumyadeep, yeah. So now using this observation, let us see कि how can we calculate sort of कि कितना water log हो चुका है at a particular bar. Okay, fine. So for this bar, how much water can be logged? Basically over here I am writing water logged in red. Okay, for this bar 1, how much water is logged? 0. Okay, for this bar let us see like how much water is logged for this bar, that is it comes out to be 1. Okay, I am just writing it, then we will see an observation, or we will try to find some pattern, okay, or some observation by these values. For this 2, how much water is logged? It's 0. Okay, 0 again. For this how much water is logged? 1, this much. For this how much water is logged? 2. For this bar 1, 0, 0, 1, 0 and 0. Okay, now let's observe this very closely. Okay, let's try to find out कि क्या हम इन ऑब्जर्वेशन से कोई सॉल्यूशन निकाल सकते हैं. ठीक है, ओके. सो आई एम सीइंग वन वे कि जहां पर भी आई एम हैविंग सम वाटर लॉगिंग, इट्स समवॉट लाइक द डिफरेंस आई एम लाइक जो भी मिनिमम हाइट है, द मिनिमम हाइट ऑन इट्स लेफ्ट, ऑन राइट and on its right, okay, the bar, the height of the bar, the minimum of them can be logged. Okay, the difference between the current height and the minimum on left or the right can be logged. Okay, so for this 0th bar, for this bar, suppose let me write down first. Okay, so for the first bar, because this is the bar where my first water logging is happening. Okay, तो इस बार को if I see very closely, so कैन आई से कि इसमें जो वाटर लॉग हुआ है, दैट आई कैन से कि लेफ्ट बार हैविंग द मैक्सिमम हाइट. ओके, ठीक है, एंड राइट बार, लेट मी चूज अ राइट बार having a maximum height. Okay, from this index I, okay, from this index I equal to 1. Okay, having a maximum height. ठीक है, तो for this first bar, left में maximum bar की height क्या है? This is 1. right में maximum क्या है? 3. मतलब this is the maximum height bar towards its right. Okay, fine. और इस खुद के height कितनी है? What is the height of this bar? ith bar, that is 0. Correct. Okay, fine. So now can I say कि isn't it कि इन दोनों में से जो minimum होगा, the minimum among this minus this will be telling me the amount of water that can be logged. क्योंकि इधर से like I'm just this current logging of water can take place if I have 2 bars which is having the height greater than my current bar. Okay, and how much water can be logged? That will be minimum of both of these. Okay, correct. Can I say that? Can I keep this proposition? let me take a random bar as well. Let me take this 2 3 4. Okay, let me take I equal to 4. That would give you a more clear intuition, I think so. Okay, so let me denote it by left bar. Okay, left bar, that is having the maximum height. For this bar, maximum height left में कितना मिला है मेरे को अभी तक? 2. Correct? This bar. Right bar, what is the maximum height I have attained till now? That is 3 for this. इसके right में 3 is the maximum. Correct? Now my question is कि how much water can be logged above this bar? Okay, this fourth one. इसके खुद की height again is 0. Can I say कि the water that will be logged will be equal to minimum of these two minus this. So minimum of these two is 2 and minus the current height 0. So that will tell me 2 units of area of water will be logged above this bar. So I have kind of got a proposition ki okay, taking the minimum of the maximum of the left and the right bar with the current bar subtraction will give me the will give me the area of water that will be above this bar. Can I say this? Is it clear to everyone? Over here, if anyone is having any doubt, let me know, else I will move forward. Okay, fine. So I'm assuming that everyone has got it. Okay. So let me take a postulate or how I will try to like form a solution of it. That is a very how to approach this intuition by observation. Okay, fine. See, so most of these problems like where there are histogram or bar sort of bars sort of things are there. So how you try ki first of all make a diagram, proper diagram, and try to find out ki okay, how much like what the question requires and can I consider something for a unit bar, for one bar. Like if I would have considered all the bars, I would have messed it up. Okay, my first observation was कि मेरे को ये पता लगाना है कि at a particular bar how much water I can have. That was my only problem to be solved. Okay, and if I can club them all, then I will get the answer for everything. So I just concentrated on one bar. I think so that was the key for this problem. Okay, fine. So for the brute force solution, like I think so what we can do for it is कि if I am at the ith bar, I will traverse from 0 to I minus 1 and get the maximum bar. Okay, maximum left I will say. Okay, and I will traverse from I plus 1 to 0 and get the maximum right. Okay, the maximum height of the bar that is on its right. Okay, and what I can say कि water logged or water I will say, okay, water will be somewhat like height kind of maximum of okay, these are already maximum. So what my postulate was कि जो भी इन दोनों में से minimum होगा sorry, yeah, thanks for pointing that out. Yeah, from I plus 1 to n minus 1 basically. ठीक है. Okay, so my water log, जितना water log होगा वो क्या होगा? That is the minimum. Let me just write it down. That will be just minimum of this maximum left and maximum right minus the current bar. ठीक है, or I will add this to my answer simply. Correct? Like kind of this is the kind of solution which I can think of, like very brute force. How will I implement it? Right? So if if I just try to write this solution out, he traverse the array from left, at each I find maximum left and maximum right. ठीक है, that is very easy कि if you are at I, just traverse from 0 to I minus 1. That's very easy, and traverse from I plus 1 to n, and this will give you this part and this will give you this part. Okay, and then just use the formula, ठीक है, which we have derived or which we have seen by the observation, okay, which we just saw. ठीक है, so if I just write down a pseudo solution for it, that would be something like this. Okay, for the first bar, can I say the first and the last bar cannot log any water. Cannot log any water. Can I say this? मतलब अगर दो बार यहाँ पर है, मान लो ये है, ठीक है, काइंड ऑफ लाइक दिस, तो इन दोनों पे तो कुछ भी वाटर हो ही नहीं सकता क्योंकि इनके पीछे कुछ है ही नहीं सपोर्ट देने को जो इसे लॉक करवाएगा, करेक्ट. तो दिस इज ऑल्सो अ वेरी इंपॉर्टेंट ऑब्जर्वेशन कि फर्स्ट एंड लास्ट बार कैनॉट लॉग एनी वाटर. ठीक है, सो आई कैन स्टार्ट फ्रॉम आई टिल n-2. कूल, fine. So now can I say कि to get maximum left, just assume that I am having a variable named maximum left. Okay, I will traverse from while just take a variable j and denote it to I minus 1 while j is greater than equal to 0 and calculate maximum left equal to max of maximum left comma whatever is my array, let's say nums. Okay, nums j. ठीक है, and similarly for getting the maximum right, I will do the same thing. I will reinitialize my j equal to I plus 1 and I will go from while j is less than n and I will take out the maximum right. Just the same thing, maximum right comma nums j. ठीक है, and simple. I will just see how much water I can log. ठीक है, and that will be simply min of using the same formula. ठीक है, maximum left comma maximum right minus height of I. ठीक है, now very important thing which we have to take care over here for the correctness of our solution. Do you all agree कि there can be a case कि जो maximum bar on left or maximum bar on right can be lesser than the current bar? If I take this case, then this bar, for this the bar on its left and the bar on its right, which is maximum, is also lesser than it. So can I say, if suppose I was at that bar which was having a height 3, so this will give me a negative value. ठीक है, so I will only add it to my answer if it's greater than 0. ठीक है, if it's greater than equal to 0, basically if it's greater than 0, then just add water, or just this is a ternary operator for if and else. Okay, and if it's not, then just simply add a 0 that okay, we can't have a negative logging, so it won't be having any water logging above the current bar. Okay, now if I closely observe this, so this is for n and this can run for n loops as well. So kind of this is giving me a time complexity of n square. Okay, and space complexity remains big O of 1. Hello Geeta. Yeah, okay, so let me know if this is clear to everyone, this brute force solution. I hope this brute force solution is clear to just John. Can you repeat question? Okay, the question is a rainwater trapping problem. Basically you can just, I think so, in the live also you can just drag back and just see the solution, like sorry, see the question. Okay. Okay. Moa, you like Manish, you always come up with the most optimized solution at the first go. I'm just now discussing the brute force solution. Okay. I think so, like I'm also getting a feeling that okay, it will turn out to be a 2-pointer somewhere around, but let's see. Okay, so till here is everything clear to everyone? Okay, we are taking maximum from left and right for each I bar. Okay, ith bar. Okay, so let's see, can we optimize more? Can we optimize? Till here, if anyone is having any doubt, just let me know. Yeah, Manish, like kind of like when I read this problem, I got that intuition of histogram wala problem. So stack is also possible, but yeah, it also takes ON space. That I feel that my next approach, like which is an optimized one, will be taking an ON space. Okay. Fine. So let me move forward. So the thing is, yeah, prefix max and suffix max. Yeah, correct. So what I was doing ki if I was at the ith bar, I was going to 0. I was going to n-1 to get maximum right, which I am denoting by MR, okay, and maximum left. Okay. Now, can I do something to get these things in constant time? If I can do something कि मेरे को अगर ये constant time में मिल जाए, तो ये हमारा n square वाला जो factor आ रहा था वो हट जाएगा, that will be removed, correct? So for this what we can do, we can use prefix max and suffix max. Okay, so how will I form this prefix max and suffix max? So this was my array. Again, I have to write this down, bro. Fine. If I could anyway copy and paste it, 0 1 0 2 1 0. Let me just take it. The array was 0 1 0 2 1 0. Sorry, because of this thing, the time is getting wasted. 2 1 0 1 3 2 1 2 1. Okay, 1 3 2 1 2 1. Fine. So what I mean by taking a prefix max, ki if I am going from the left, okay, if I am at the ith point in my prefix max array, these are basically arrays. Okay, so till the ith point I will be able to know in a constant time ki what is the maximum value on the left. I have occurred on it. Okay, I have seen. So for the starting value, this is only the maximum. For this till here, 1 is maximum. Now 1 is maximum, okay, because this was the maximum. For 2, now it get updated. 2, okay. So 2 I encountered over here. For this 2, for this also a 2 will be there. Now again, I have got a bigger bar, so 3. And now for the rest of the values, this will only be the bigger element on its left. So 3 3 3 and 3. Okay, so this is basically my prefix max, which I can easily pre-compute. Okay, I can easily pre-compute this. Fine. Now coming to suffix max. So for the last element, this is only the greater element on its right. 2. I'm quickly forming it. Just let me know if anyone is not familiar with prefix max and suffix max stuff, then I will explain, or else I will quickly move forward. 2 2 2 3, and now for every element, how many? this is 2 in space. O in space would be taking, yeah, I will reduce this to O in space. Okay, just wait a minute. I will reduce this to O in space. I'm seeing something which I can do. I know this is a 2 in space solution. Okay, 3, then 3, for this 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 3, and for this 3. Okay, so this is my suffix max and this is my prefix max. Okay, so can I say, if suppose I was at this bar, okay, ith bar, so now taking suffix I, okay, or taking suffix I plus 1 and suffix max, and taking prefix max I minus 1 is giving me maximum left and it is giving me maximum right. Okay, if I pre-compute this out of my loops, out of my those loops where I am traversing the array. Okay, so is this thing clear to everyone? Okay, I can use something like this and I can get my maximum left and maximum right in a constant time. This is kind of like pre-computation stuff. Okay, I took a session like I think so that was the second or the third session taken by me. There only I took a problem where a prefix sum or something like that was used, and there I told ki these kind of stuffs are very, very, very helpful in the place where we want to do some pre-computation. Okay, till here, if anyone is having any problem, let me know, because now if I have this array, my solution will be very trivial. As before, I will start from I equal to 1 and will go till n minus 2, and what I will do, I will calculate ml by prefix max. Okay, I'm just writing the solution. Till then, if anyone is having any doubt, just let me know. And mr will be prefix, oh sorry, my bad, suffix max I plus 1, and waterlogged will be min of mr minus height of the current bar. Okay, height of the current bar. Okay, and if this is greater than equal to 0, then only I will add it to my answer. This was my solution. Okay, I reduced my solution, or I did I came up to this where I removed those two inner loops to get these two values, and over here I am using those two arrays which I have calculated before. Okay, so this solution boils down to a time complexity of, because all these operations are of constant time. Okay, so this will come out to be big of n, and space complexity over here is twice of n, right? Because we are maintaining two arrays. Okay, we are maintaining two arrays. Now, can we reduce the space? The fact is, can we reduce the space over here? And all the people who are not even familiar about dynamic programming, so having prefix max, prefix sum, prefix mean, something like something kind of that is kind of dynamic programming thing only, because you are using something you have calculated in past. Okay, or you have stored it somewhere. Okay, so this is also kind of like dynamic programming approach only for our optimization. Now the thing is, can we reduce space? Like, can we do it in big of n space? That means we only need okay, so can I say if I have to do it in big of n space, so I need either of them. या तो मेरे को ये चाहिए और या तो मेरे को ये चाहिए. ठीक है. Now, on the nature of our traversal, out of the nature of my traversal from left to right, I am doing. Can anyone tell me which should be removed? Prefix, like prefix max should be removed, or suffix max should be removed? Can anyone tell me which one I should remove, considering my nature of traversal is from left to right? What is the thing which I can do while I am traversing in this loop, which I am doing redundant over here, kind of in one of these two. So can anyone tell me which one I should remove? Yeah, exactly. I should remove prefix max. Why? क्योंकि prefix max what it is, till my ith point अभी तक मेरे को maximum value क्या मिली है? Can I say that this is only my prefix max I? So while I am traversing from I to n-1, I can take a max ml left and I can initialize it to height of 0. That is the first bar, and I can simply have that maximum value till left I have incurred till now by simply doing this. Okay, and I need to use suffix max because I need to get my maximum on the right as well. So for getting the maximum right, I can use suffix max I. So can I say I can remove this? This is something redundant or trash for me. Yeah, exactly, Rahul. Correct. Fine. So I removed this, and now this operation to remains the same. I'm just moving over here. Okay. Basically our formula I can write. Okay. So over here I have reduced my solution to big of n space. Okay. And the time was, this is the space complexity, and my time complexity is big O of n. Okay. Big O of n. Correct. So till here, is the thing clear to everyone? Is it clear to everyone? How we have reduced the solution from on square to on, from 2n space to on space. Till here the things are very intuitive, right? Okay. Now let me think, can we optimize further? And optimizing further means in terms of space. ठीक है, टाइम में तो हमने जो भी मैक्सिमम पॉसिबल या मोस्ट ऑप्टिमल तक हम पहुंच सकते थे, वी हैव रीच्ड. In terms of space, okay, can we optimize more on space? Like suppose if you were in an interview and if I would have given the solution till here, ठीक है, so the interviewer would say, okay, can we optimize further on space? So then I have to think something. Okay, I can optimize further on space or not. Okay, and now I'm taking a shorter array. I have 420325. Okay, 420325. I'm just taking it because 420325 because that takes a huge amount of time to copy and paste. Yes, exactly. In this problem, two pointer has never been intuitive. Yeah, right. I'm also getting a feeling कि two pointer थोड़ा सोचना है यहाँ पर. It will be a bit tricky, but ठीक है. Let's see. Like how one can think we can use something sort of two pointer over here. Okay, two pointer. I would like just give you a generic sort of statement कि whenever you are dealing with a problem in arrays where you have to deal with something pairs, okay, you have to get two pairs, or like suppose in this problem we are dealing with ML and MR, which is basically an element. These are only an element of an array, right? So अगर ऐसा कहीं भी जगह होता है ना, तो try to think कि okay, can we think of something two pointer, can it resolve it? But two pointer requires some strong propositions. ठीक है, fine. So now let us move and see कि if we can optimize on space. ठीक है, fine. So suppose if I start from here and keep two pointers like this. ठीक है, this is my, or I'm very sure कि first and the last one will not be like the desired, like will not contribute in our answer. ठीक है, so I'm starting from the first and the n-2. ठीक है, fine. अब यहाँ पर सोचते हैं कि इसके लिए हमें चाहिए क्या था, इसके लिए हमें चाहिए था मैक्सिमम ऑन द लेफ्ट एंड मैक्सिमम ऑन द राइट, करेक्ट. वी वांटेड दीज टू थिंग्स फॉर फाइंडिंग द वाटर लॉगिंग अबव दिस बार. फाइन फाइन. नाउ कैन आई डू समथिंग लाइक दिस कि kind of whatever maximum left I have incurred till now over here and whatever maximum right I have incurred till now, ठीक है, can I use these things something sort of to get a proposition की like, क्योंकि in your CP journey have you come across such problems where 2 pointers were used but not iterative? Just curious. In CP, like mostly I have encountered problems where like yeah, kind of trickier problems are there where like getting an intuition is quite difficult, but yeah, with practice you can observe, or like suppose like in this problem by the approach which I gave you, कि if you are having something sort of an array and you want to find some pair sort of thing, ठीक है, तो वहाँ पर what you can do is you can think of 2 pointer. So if I am sure कि okay, now I am going to think in terms of 2 pointer, so I will take a simple case just like I am doing over here, and I will try to have some proposition, because 2 pointers always require a strong proposition which will tell me where I like at what condition where I will move my pointers, correct. So kind of sometimes it's not intuitive, but yeah, if you have some like practice of problem solving of like variety of problems, then kind of your mind can come up to a solution like this. Okay, fine. So over here maximum left and maximum right. Okay, maximum right. Can I make some propositions or conclusions over here? Okay, so if I say कि my maximum left at this point, till this point my maximum left is lesser than maximum right, and generally propositions are like this only, कि कोई किसी से छोटा होगा, बड़ा होगा, नहीं तो बराबर होगा, kind of that, ठीक है. 2 pointers में generally ये चीजें चलती हैं, ठीक है. So if my maximum left is lesser than maximum, why I am writing it as height, bro? Okay, maximum right, ठीक है. So can I say कि this bar whatever not hit and trial, you can say that these things comes up like after you have done quite of practice, okay, over different variety of problems. Like what I think, like how I have prepared for the stuffs for the interviews or for like when I used to do CP and all those stuff. So what I did was कि try to solve all standard problems, easy, medium, hard of a given topic. Then you can somewhat sort of like get an idea कि can I use that way? Is it a variation of that? Like then you can map out the things. So kind of you can do that. Like this is a very standard problems on 2 pointers on stacks. I'm not taking it on stacks today, but someday later I will be dealing a solution. I will be taking up a solution of stack as well for this problem. Okay. So over here, maximum left is less than maximum right. ठीक है. तो मेरे को क्या मतलब था कि ये अपने लेफ्ट साइड वाली वॉल से अभी तक जितने लेफ्ट साइड में आ सकता है उससे वो कितना वाटर लॉक कर सकता है. सो कैन आई से दिस कि इफ मैक्सिमम लेफ्ट इज लेस देन मैक्सिमम राइट, सो आई कैन एश्योर कि ठीक है, आई कैन फाइंड आउट कि विद मैक्सिमम लेफ्ट हाउ मच वाटर दिस bar can take out of it, and what it will be just maximum left minus height of the ith bar, kind of like this. ठीक है. Can I say this? कि if I have got this proposition कि अभी तक का मेरा मैक्सिमम लेफ्ट में जो बार था और मैक्सिमम राइट में जो बार था, मैक्सिमम लेफ्ट वाला छोटा है, तो that can contribute to the water can be that can be logged above my current bar, and that can give me a solution, that can give me a contribution, that would be right to say. Or if maximum right is having the smaller, क्योंकि as I told, अगर यहाँ पे मान लो कुछ ऐसा था और यहाँ पर कुछ ऐसा था, तो इन दोनों के बीच का जो मिनिमम है वहीं तक ये वाटर लॉक कर पाएगा कुछ, ठीक है, यहाँ ये वाला पार्ट, तो मेरे को मिनिमम वाले पे ध्यान देना है, ठीक है. मैक्सिमम राइट लेस देन मैक्सिमम लेफ्ट. I am also saying that this solution is not very intuitive, this 2-pointer solution for this problem, but yeah, it can be if you visualize it. Okay, and over here water plus equal to the same thing, right, minus right, okay. And if I have done for this bar, if I am done for this bar which is at the which is at this pointer LO, and then what I will do, I will simply move ahead of it. Okay, yeah, I have got the answer for this bar, and if it's on its right, then what I will do, I will simply come to the center. So basically these pointers will go in this way, and for each bar I will be just checking these propositions. Okay, these are my propositions, basically. Okay, is the solution clear to everyone? And then I will start, I will code it down, and you can see over here, it will go something like this. While low is less than high, I will just update my maximum left which I have incurred till now via this. Okay, and I will take out the maximum right as well in this manner. Height RI or HI. Okay, and what I will put these propositions over here, that if maximum left is less than equal to maximum right, okay, then simply just calculate for this bar कितना water ये अपने left bar से lock कर सकता है. ठीक है, and if I have got my answer for this, then I will move ahead with my low pointer, and else I will just see कि my current bar अपने right side के maximum bar से कितना water lock करवा सकता है. This is height low, this is height HI. basically we don't have any I pointer over here. ठीक है, HI equal to HI minus 1. Perfect, and we will do. So this is our logic, and over here you can see this loop will run for n times, okay, n iterations, and these all stuffs over here takes constant time, and we have not used any extra container. So the time complexity for this problem would be big O of n, and the space complexity will be constant. Okay, so is this solution clear to everyone? Did you get the intuition ki why I can make this proposition? Why I can make a proposition ki if my maximum left is lesser than maximum right, then this maximum left will definitely contribute to the logging of the water at the current bar. That's why I have just used that. If you can visualize it. Is this clear to everyone? I think so. And one more thing, if anyone wants the implementation for the same, I will implement, or this is a very basic implementation. You can implement it in any language. This is exactly, you have to implement these things, taking care of these variables. Okay. So let me know if I should implement it, or if not, then it's fine. Then this is the most optimized solution for this problem, and I hope it was clear to most of you how or all of you that how we boil down our problem from just whole chunk of bars of waterlogging to a single bar. I focused on a single bar कि ठीक है एक बार के ऊपर कितना वाटर लॉग हो सकता है. For that I made some observations. Why that observations? I found out कि okay, I can implement that thing in a similar way, that is an O(n) square approach. Then I tried to find out कि if I am doing something redundant or I can optimize it. Then I optimized it and move it to big O of n, but we were still using some space, so I reduced on space, and finally we have a 2-pointer solution. So is this clear to everyone? The next part or the next question I'll be taking from 9:15, which will be on the other stream, Walmart interview questions 3. So you can join there. Okay. So if in this problem, yeah, kind of, I can say that's why it's a hard problem, and it's even asked in companies like Google and I think so Amazon as well. It's a hard rated problem on Elite Code and on interview bit as well. Don't worry, like the next question is a bit lighter. Okay, it's a medium level problem that I will be discussing at 9:15 on the other stream. Don't forget to join that. Okay. But I hope Rahul, like I was able to make you get the intuition for it. I hope you will never forget it. Okay. Okay guys, so thanks a lot for attending this session, and I hope you all enjoyed and learned something good out of it. Thank you everyone again. Do like, share and subscribe this channel for the upcoming lectures and my sessions. Okay, thank you everyone again.